question number 1 is define the term solution and how many types of solutions are formed. Write briefly about each type with an example. See, first of all, this solution is a homogeneous mixture. हमें पता है कि जनरली सॉल्यूशन दो टाइप के होते हैं, homogeneous and heterogeneous. Here solution is a homogeneous mixture. So whenever two or more types of different compounds are mixed together and if a homogeneous mixture is formed, then this mixture is known as a solution. Okay, so this is an explanation about the solution. So the definition of solution is a homogeneous mixture of two or more than two components is called solution. Okay, so this is the definition of solution. Now based on the physical state, there are three types of solutions: solid solution, liquid solution and gaseous solution. Now we know that solvent and solute are combined together to give a solution. Now solvent has more proportion and solute has less proportion. So we can say that the physical state of a solution is equal to the physical state of solvent. So we can say that physical state of solvent in solid solution is a solid, for liquid solution is a liquid, and for gaseous solution gas. Now we are taking types of solutions. Now we know that there are three types of solutions: solid solution, liquid solutions and gaseous solution. And as we know that the physical state of the solution and the solvent is same. So in a solid solutions, physical state of solvent will be solid, for liquid solution liquid, and for gaseous solution gases. Now if we take solid as a solute and it is mixed with solid, so at that time generally heterogeneous mixture is formed. So for that, generally whenever two solids are mixed together, generally they are in molten state and then they are mixed and they are kept to be cooled. An example is copper dissolved in a gold. Okay, so for the toughness, copper is mixed with gold so that its carat, means the concentration of gold particles, decreases. And remember, all the alloys are the solid solution like brass, bronze, etc. If we dissolve any liquid in a solid, and the example is amalgam of mercury with sodium. So if sodium is mixed with it, so it is known as sodium amalgam. If zinc is mixed with mercury, then it is mercury zinc amalgam. When gas is dissolved in solid, and the example is solution of hydrogen in palladium. See, at that time on the surface of palladium, hydrogen is coated. A coating of hydrogen, a layer of hydrogen is formed on the surface of palladium. and here also homogeneous mixture is formed. Okay, next. In a liquid solution, if solid is mixed with liquid, then liquid solution is prepared, and the example is glucose dissolved in water. Next, liquid is mixed with liquid, and the example is ethanol dissolved in water. And gas is mixed in liquid, then example is oxygen dissolved in water or soda water. Remember the another example, soda water. Now a solid is mixed with gas, example is camphor in nitrogen gas. Say camphor is a sublimative substance, so the mixture of camphor and nitrogen is a gaseous solution in which solute is solid and solvent is gas. When liquid is mixed with a gas, so at that time chloroform and nitrogen gas, this mixture is known as gaseous solution. And when gas is mixed with gas, then the mixture of an oxygen nitrogen gas means mixed air is an example of gaseous solution. Okay, so remember, so our first question is over now. Now we are taking question number 2. You are given that suppose a solid solution is formed between two substances, one whose particles are very large and another whose particles are very small. So what kind of solid solution is likely to be? See, whenever a solid solution is prepared and both of the substances are solid, at that time generally interstitial solid is prepared. In this type of solid substances, the solvent particles are having larger size. Okay, so here we can say that solute has smaller size. So, solute particles which are having a smaller size, they will set at the interstitial void. Okay, they will set into interstitial void. So such solid solution is known as interstitial solid solution, and the example of it is a WC. See, W is a symbol of tungsten. Okay, tungsten means heavy stone. Tungsten, it's actually stone. Okay, it's a Swedish name, but its German word is a wolfram. That's why it has a W symbol. So WC is a tungsten carbide. Okay, carbon has a smaller size, so it will set into the interstitial void, and tungsten have a larger size, so it has a more proportion. Now in the next question, you are given that define the following terms: mole fraction, molality, molarity, and the mass percentage. See, first is the mole fraction. So mole fraction is a ratio of the two things. See, if we take here x of solute, so at numerator we have to take number of moles of solute, and at denominator we have to take the total number of moles of solute and solvent. Similarly, if we take mole fraction of solvent, so it will be N of solvent, and at denominator we have to take N of solute and N of solvent. So basically the definition of the mole fraction is the ratio of the number of moles of component and total number of moles of mixture is called mole fraction of that component. मीन समझ में आ गया होगा. अगर आपको मोल फ्रैक्शन ऑफ सॉल्यूट फाइंड आउट करना है तो न्यूमरेटर में लेंगे नंबर ऑफ मोल्स ऑफ सॉल्यूट और डिनोमिनेटर में लेंगे हम टोटल नंबर ऑफ मोल्स of solute and solvent. Similarly, x of solvent means n of solvent divided by n solute plus n solvent. Now next is molality. So molality means number of moles of solute per 1 kilogram of or 1000 gram of solvent is known as molality. Okay, so the formula of molality will be number of moles of solute divided by mass of solvent in kilogram. Third is molarity. Molarity means number of moles of solute per 1 liter of solution is called molarity. So the formula of molarity, number of moles of solute and it is divided by volume of solution in liter. Next is mass percent. See, mass percent has total two parts. Number one is percentage W by V and next is percentage W by W. So this one is known as mass volume percentage and here mass percentage. Okay, so the definition of percentage W by V is in 100 ml of solution dissolved, mass of solute is called percentage W by V and it has a formula mass of solute, volume of solution, mass of solute in gram, volume of solution is in ml and it is multiplied by 100. Similarly here definition is in 100 gram of solution dissolved, mass of solute is called percentage W by W and a formula will be mass of solute in gram, mass of solution it is also in gram and it is multiplied by 100. Next question is concentrated nitric acid is used in laboratory work is 68% by mass in the aqueous solution. So what should be the molarity? So you are given percentage W by W, that is 68%, and another thing is density, it is 1.504 gram per ml. So simple, here we can calculate molarity by using the relation between percentage W by W and density and molarity. So the formula is percentage W by W into density into 10, and it is divided by molecular mass of solute. Here it is 68, density is 1.504 divided by molecular mass of solute, that is 63 for HNO3. So by calculation we are getting the answer 16.23 molar. Okay, so it is over. Next question is, a solution of glucose in a water is labeled as 10% W by W. Then what will be the molality and mole fraction of each component in the solution, and density is given to you 1.2 gram per ml, and you are asked the molarity. So same as the previous question, here we can calculate first molarity by using the formula. Molarity equals percentage W by W into density into 10 by molecular mass. So W by W is 10, density 1.2 into 10, and it is divided by 180. So final answer is 0.666, so it is 0.67 molar. Next is, you are asked molality and the mole fraction. See, first of all we have to write the meaning of percentage W by W glucose solution. So meaning of percentage W by W is 100 in 100 gram of aqueous solution, 10 gram of glucose is dissolved. Okay, so here we can say that 100 gram is a mass of solution and 10 gram is a mass of glucose. So by subtracting 10 from 100 we will get mass of solvent, and solvent is water. ओके, तो एक्वियस सॉल्यूशन, सॉल्यूशन के अंदर ये सल्यूट विच इज डिसॉल्व वो इंक्लूड हो जाता है. तो अगर हम मास ऑफ सल्यूट, मास ऑफ सॉल्यूशन में से सब्सट्रैक्ट करें तो हमें मास ऑफ सॉल्वेंट मिलेगा. सो इट इज 90 grams. Okay, next, so based on it we can calculate number of moles of solute. It is 10 by 180, and number of moles of solvent, it is 90 by 80, so it will be 5, and here we are getting 0.0555, so it is 56. So the mole fraction of solute, it will be, X solute will be number of moles of solute, that is 0.056, and it is divided by the sum of moles of solvent and solute, so 0.056, and it is divided by 5 plus so it is divided by 5.056, and the answer is, so the answer is 0.011. Next, similarly, X of solvent will be 1 minus X of solute, because the total number of mole fraction will be 1. So 1 minus 0.011, and our answer will be 0.989. So Here we have calculated the mole fraction. Now molality is remained. So molality can be calculated by using the formula mass of solute divided by molar mass of solute at denominator mass of solvent in kilogram, but if we take in a gram then we have to multiply by 1000 at numerator. Here mass of solute is 10,000 at denominator. The molecular mass of solute will be 180 and mass of solvent in gram will be 90 and answer will be 0.617 molal. Now in the next question you are given that how many ml of 0.1 molar HCl are required to react completely with 1 gram mixture of Na2CO3 and NaHCO3 containing equimolar amounts of both. See, in this question, when Na2CO3 so in this question Na2CO3 will react with HCl to give NaCl, CO2 and water. Equation can be balanced very easily. 2Na, okay, then 2Cl, then it is HCl is multiplied by 2, 1 carbon CO2 and 1 H2O. So overall equation is balanced. Similarly, NaHCO3 also can react with HCl to give same NaCl, CO2 and water. So Na and Cl is obtained and equation is already balanced. Now here stoichiometric relation is formed that Na2CO3 it is 1 mole. So for complete reaction of 1 mole of Na2CO3 2 moles of HCl are required. Similarly, to be react 1 mole of NaHCO3 1 mole of HCl is required. Now you are given that 1 gram of mixture and it contains some mass of Na2CO3 and some mass of NaHCO3. So here we have to assume that suppose x gram of Na2CO3 is present into it. So at that time the mass of NaHCO3 will be 1 minus x gram. Again 1 gram of mixture containing Na2CO3 and NaHCO3 is taken. So if we take x gram of Na2CO3, at that time the mass of NaHCO3 will be 1 minus x because the sum of masses should be 1 and here we have assumed that the mass of Na2CO3 is x. So at that time mass of NaHCO3 will be 1 minus x. Okay, next. Now this mixture contains Na2CO3 and NaHCO3 equimolar amount. Equimolar amount means number of moles of both of the components are same. So at that time here we can say that the number of moles of Na2CO3 and number of moles of NaHCO3 both are same. So number of moles means mass that is assumed by us, that is x, and it is divided by 106. Another side 1 minus x and it is divided by 84. So now if we solve this equation, then 84 is multiplied to left hand side, 84x, and 106 is multiplied with 1 minus x. So 84x Here is 106 minus 106x. 106x is shifted to left hand side. So in addition we are getting 106x equals to 106. So by addition it is 190x equals 106, and then x can be calculated, and it is 106 by 190, and it is 0.558 grams. So this will be the mass of Na2CO3. So the mass of Na2CO3 is 0.558 gram, and then number of moles of Na2CO3, it will be 0.558, and it is divided by 106 with its molecular mass. So we are getting the answer 0.0053. Similarly, mass of NaHCO3, it was 1 minus x. So 1 minus x, 0.558, by subtraction we are getting 0.442 gram. So the number of moles of NaHCO3 divided by 84 with its molecular mass, and here we are getting same 0.0053. So the number of moles are same, and that was given into the question, and number of moles are determined by us. Now the stoichiometric relation. Now the stoichiometric relation of Na2CO3 with HCl, it is 1 mole and 2 moles based on chemical reaction. And here 0.0053 mole. Then how many moles of HCl are required? Answer is 0.0106 moles. Another side, NaHCO3 HCl, relation is 1 mole versus 1 mole. So 0.0053 mole, then same. So total number of moles of HCl which are required are the sum of 0.0106 and 0.0053, and by summation we are getting 0.0159. Now we know that the formula of molarity equals number of moles upon volume in liter. So volume in liter equals number of moles upon molarity. Number of moles which are required are 0.0159, and it is divided by molarity, that is 0.1. So 0.159 liter, and you are asked the volume in ml. So volume in ml will be multiplied by 1000, so 159 ml. So this is our answer.